All right, good morning, good morning. Welcome, welcome. Today will be the first video for the spring 2018 semester. You guys are excited to learn new stuff in Algebra 2. Okay, so game plan today is solving rational equations. So what on earth does that mean? Lately, we've been solving, like, let's say, if we have this rational expression and this rational expression, we add them or we subtract them, and they have different denominators. We were playing with that game yesterday. But now, what happens if we have an equal sign here? And the question is, solve the following equation for x, and give evidence that your solutions are correct. Okay, so how do we solve for x in this equation? All right, that's what we want to do. All right, so for the lesson today, we're only going to solve this question together, and this question together. And then the rest, you're on your own with your classmates. So, okay, let's get it going. Here, the same question. Let me zoom out a little bit. Perfect. Okay. So x over 2 plus 1 over 3 is equal to 5 over 6. Now, how can we get x by itself? That is the game plan. Well, here, remember, we have two different denominators, and somehow we want to combine these two, right? We want to make our life much simpler. So here, if we have 2 and 3 as a denominator, game plan always is to change these two so they have the same denominator. And that same denominator we want them to have is the LCM of 2 and 3, right? And the LCM of 2 and 3 will be 6, because what are the multiples of 2? They're 2, 4, 6, 8, 10. What are the multiples of 3? 3, 6, 9, 12. And the lowest is that 6, right? So we're going to use that 6. So this becomes 6 over here. This becomes 6 over here. That plus sign continues. And this 5 over 6 just, this remains the same. So we're going to change the way this looks to something over 6. So the way you do this is you ask yourself, from 2 to 6, how do you go from 2 to 6? You're going to multiply by 3. So here, you're multiplying this by 3, right? And you're also, whatever you do to the bottom, you have to do to the top, and you're going to multiply the top by 3 as well, right? So then this becomes what? This becomes 3x, right? And then what happens here? How do you go from 3 to 6? This is times 2, and then this has to be times 2. So now you have 2 on top, because 1 times 2 is 2. And now look, we successfully have the same denominator. Now we can combine these two fractions, right? So now we have 3x plus 2 all over 6 is equal to 5 over 6. Okay. Now, what happened here? We have 3x plus 2 over 6 is equal to 5 over 6. So how do we continue? Well, notice that here they have the same denominator, right? Like on both sides of the equation, they both have 6 as a denominator. So in reality, you see the denominators are equal, so then the numerators are equal. So this, you're allowed to say here that 3x plus 2 is equal to 5. Okay? If this confuses you, just stop for a second, raise your hand, and I could explain this more to you. Okay? But you're allowed to say this because the denominators are the same. So now that 3x plus 2 is equal to 5, this you know how to solve, with your eyes closed. You just do minus 2, 3x is equal to 3, divide by 3, x equals 1. Okay, and that's it. And one thing that we should do is, let's actually check our answer. Let's see if x equals 1 will work, because we have to check to see, like, let's say if you plug it in, will it work? Well, let's see. If x is equal to 1, so then 1 over 2 plus 1 over 3 is equal to 5 over 6. Okay? I give you that time. If you want, you could pause the video and check for yourself. But it will work. Okay. So that's kind of what we did. That was kind of just like a little warm-up. Now let's look at this one. Here, for this question, you have 2x over 9 plus 5 over 9 is equal to 8 over 9. Now, what is different from this problem to this problem? Here, the denominators are different. So what did we have to do? We had to kind of change and manipulate them around. We changed them to some 6. But here, life is very easy. You have the same denominator in all 3 places. So you could just do 2x. Here, we can add these two rational expressions because they have the same denominator. So 2x plus 5 over 9 is equal to 8 over 9. And that same idea of if they have same denominator here, you see like this fraction is equal to this fraction. These denominators are the same thing here. These denominators are the same. So then the numerators must be equal. That has to be true. So then now here you can say that 2x plus 5 is equal to 8, right? And now you know what to do here. You just do minus 5, and x is equal to 2x is equal to 3, right? And then divide by 2, when x is equal to 3 over 2. Okay? It's okay to get an answer as a fraction. And if you want, what you could do is you could substitute it into here. If you want to check it real quick, what would it be? It would be 2 times 2 over 3 over 9 plus 5 over 9 is equal to 8 over 9. And if you do the check for this, it will work. Okay, so far not too bad. Only 6 minutes in and not too bad. Okay, now let's look at the third question on your sheet. It should look like this. It is this question for on that front page, right? It'll be, we did these two questions. Now let's do this final question and then we're done. Okay, so here you have x plus 3 over 12 is equal to 5 over 6. Okay, and there's a reason why I have, let me zoom out a little bit. Okay, that's better. There's a reason why I had 3 different versions of it. Because when I saw this, I said, there are multiple methods for solving for x. And when we're learning this style of math, there is no one way. Okay, there are multiple ways of solving for x here. Okay, so what I want you to do is try and solve this by yourself first, right? Pause the video and solve for x. And then what I'm going to do is I'm going to show you multiple ways of solving for this. And then, yeah, okay, so let's say 3, 2, 1, you pause the video, you have a solution, and you want to see the different ways. Okay, one way is, you remember that idea that we just did over here? Where was it? Ah, yeah, here. You remember here that once we have the same denominator, we can say that the numerators are equal, right? Where was it? Here. You can kind of do that here. What you could do is, a very sneaky little trick is, here this is 12 and this is 6. So how can we make these two have the same denominator, right? Well, just why don't you just do this? Multiply this by 2 over 2, right? If you multiply this by 2 over 2, you get this is equal to 10 over 12, and x plus 3 over 12, right? So this, we didn't change anything about this, but we just multiplied 2 over 2 to this fraction, and the reason we did that was because we want to get the same denominator so we can say that this is true, right? But what is the reason why we're allowed to do that? Remember, that idea of multiplying by something over the same thing, this is just 1. And you're allowed to do this. This little trick of multiplying by 1 with different ways of having it look is very, very important, okay? Because remember, 5 over 6 is equal to 10 over 12. These two have the same value. And then what did we accomplish? Same denominator. So now the numerators must be equal in this case. So x plus 3 is equal to 10, right? And you do minus 3, x is equal to 7, okay? And if you check it, right, check, let's just check real quick. 7 plus 3 over 12 is equal to 5 over 6, right? So 10 over 12 is equal to 5 over 6, right? And that is true. That is true. You just divide this by 2, divide this by 2, right? You're just simplifying this, divide this by 2, divide this by 2. And then you get 5 over 6 is equal to 5 over 6. Okay, so this works. All right, so what's another way? What's another way of solving for this? Because this was a nice little trick, right? And this is where that idea of being creative is very important, okay? We are developing creativity when solving these problems, okay? Let's look at this one. Another way you could do is cancel the 12, right? I'm sorry, we're going to cancel the denominators. And the way we can do that is multiply both sides by 12. Okay? just multiply both sides by 12. Because if you multiply both sides by 12, you're going to knock out the denominators, okay? So here, when you do this, this 12 and this 12 cancel, and this becomes x plus 3. And this one is, what's 12 times 5? That is 60, right? 12 times 5 is 60. And 60 divided by 6 is 10. So this is equal to 10. And then what did we get? We have x plus 3 is equal to 10. The same thing we got kind of over here. And then minus 3, and x is equal to 7. Okay, so that was another nice little trick we could have done. But this is one more. Let's try another one. This is your famous cross multiplication. Okay, you can also cross multiply here. And some students get confused, Mr., when can I cross multiply? For example, last class, I remember somebody said, oh, Mr. G, if you have a over b times c over d, you cross multiply. You cross multiply here to here and here to here, right? And you get bc equals ad. That is absolutely false. The only time you cross multiply is when you have a over b is equal to c over d. Basically, when you have one fraction equal to another fraction. That's when you're allowed to cross multiply, okay? Not when you're like, when you're multiplying two fractions or something. So here, let's cross multiply, right? 12 times 5 is 60, right? Okay, actually, no, let's put it on this side. 60. And then what do we do here? You just do 6 times is equal to 6 times x plus 3, right? And now here, what do we get? We get 6x plus 18 is equal to 60. And then what do? We do minus 18, and 6x is equal to 42, right? And then if you divide by 6, x equals 7. So we did it. We solved multiple ways of solving for this. And what I want you to do and what I want you to think about is, for when you take your headphones off, is group discussion. Which method did you prefer? Okay, if you had to choose which way you like to solve this problem, or maybe you solved it a different way, you could explain it to the class, but which way did you like? And not only which way did you like, and why, does one method seem more efficient than the other method? Okay, like we have to learn how to do things in multiple ways. All right, and that's it. All right, that is it for today. All right, I will see you in class.